Naval avionics equipment routinely operates in a wide variety of environmental conditions associated with the aircraft in which it is installed. No environment is more demanding of men and equipment than that associated with carrier operations.
I can manage these plugs. Let you go inside and get another set from supply.
Okay.
The following scenes might be part of a typical day aboard any operating carrier. The constant pressure to maintain the highest possible operational readiness frequently leads to developing techniques designed to reduce the time between isolating a maintenance discrepancy and replacing defective components with operational units. Documentation and material issue procedures are standardized to permit the most expeditious handling possible. Individual issue room procedures sometimes introduce time delays.
Okay, wake up. What do you want? Hey, Gil, got an order for you. Okay, here's your paper here. Just go ahead and sign it. Take care of it. Do I get a copy of that, man? No, don't need one. Thank you. See you later, man. That's good. Go back to sleep. Yeah, I think I will.
And some shortcut handling procedures are self-defeating. Removal and replacement of avionics gear is a time-consuming, difficult job under any circumstances. At sea, with the time pressure of a launch, it doesn't help much when supposedly RFI equipment turns out to be non-RFI. It means a lot of extra effort and time in replacing the gear in the airplane.
He just said I owe you, man. Ain't another one. Hey, Gil, need another set?
Supply system.
Most pieces of avionics equipment for aircraft are expensive. In addition, avionics systems frequently come in more than one oversized component, which adds complications when negotiating restricted spaces. A mishap with this particular set could cost in excess of $80,000.
About time.
Watch out for the hose! This better be a
Two
good
avionics systems, two short trips across a large pressure hose. About $100,000 repair costs, plus an A6 that couldn't fulfill its mission. Delicate avionics gear should always be handled carefully. Use of available carts is permissible, provided padding is used to protect the equipment. A minimum of 3 inches of padding should be used to protect delicate components. Because of the high cost of avionics equipment, plus lead time of from 9 to 18 months for the manufacture of new replacement parts, often an RFI item is not available when needed.
Did you find that antenna yet?
No, I don't think we have one. Guess you have to send it to IMA for X-Rep.
Moving heavy, bulky gear aboard a carrier always seems to be a problem. While there are many ways of approaching a task, the immediate solution may start out all right, but doesn't always end up as intended. A simple goof, a well-meant substitute for the proper handling techniques. Result? A serious gap in the ship's air defense coverage. A multi-million-dollar plane that can't fulfill its mission. And degraded carrier defense capability. Just a little thought and care could have prevented all this by following the proper procedure.
Find that antenna yet?
No, I don't think we have one. You better send it to IMA for X-Rep. Hey, Gil, how about getting Joe to get that antenna cradle? You know, the hernia bar?
Yeah, I know the mother.
Just a few extra minutes of locating the proper handling equipment can make all the difference between a seriously damaged antenna and one that can be repaired. And ultimately, the difference between a grounded aircraft and one that is operational. Aboard a CVA, there never seems to be quite enough room for the thousands of items which must be stocked, including easily damaged gyros and inertial systems. Mistake number 1, improper storage. Mistake number 2, internal shock damage. Mistake number 3, providing protective wrapping too late and issuing the dropped gyro without checking its condition on the IMA test bench.
Putting the new gyro in?
Yes, sir.
How's it look?
Pretty good, sir.
Great, I don't need it another hectic night like last night.
He's flying onto the beach. He doesn't know he has a precessed gyro.
The platform done put on the gyro on the scope. Roger. Gyro's on the scope now. She looks good.
The result of mistakes 1, 2, and 3. He meant well. He thought he was doing his job. The result? A pilot loses his life. A multi-million-dollar A6 is totaled. Far-fetched? No, it happens all too often. Why? To understand how this could happen, let's look at a typical A6 gyro platform with the cover removed. It is a complicated, ultra-sensitive device with gyro wheels mounted in bearings that spin at 25,000 revolutions per minute, more than 400 times per second. To withstand this speed for hours at a time, these ball bearings must be machined to perfection. Shock and mishandling of the gyro can interrupt the perfection of this precision instrument and result in the display of erroneous information on the pilot's indicator. Ball bearings are the problem children of gyros. Each gyro platform has many of these bearings. Magnified, the rolling ball contact looks like this. The highly polished surfaces of the bearings and the races provide which is virtually free of friction in a properly functioning gyro. When the gyro is bumped or dropped, the ball bearings are driven into the polished surfaces of the bearing race, creating indentations which act like chuck holes in a highway. The increased friction of the bearings, spinning at 25,000 RPM, causes the gyro to precess or tilt. Continued operation of the gyro will cause the indentation to grow and magnify the gyro error. This is the effect of continued operation of this damaged gyro. As the indentation continues to grow, the gyro precession causes erroneous information to be presented in the cockpit. If the pilot should enter instrument flying conditions with this faulty gyro, he would level his aircraft according to his attitude indicator. This could cause a most hazardous flight condition to develop, which might not be recognized by the pilot in sufficient time to recover. Stowage of gyros, inertial system, attitude indicators without proper protection on unpadded shelves is a major cause of damage. Gyro indicators are capable of functioning 2,000 hours without failure. However, even a 2-inch fall to a hard surface is enough to cause a premature failure, usually within the first 50 hours of operation. This new container has been designed to absorb normal handling aboard ship. Stowing and lashing these containers on properly padded shelves will help eliminate major disasters caused by premature equipment failures. External reusable containers must always be retained for offloading avionics equipment. Expensive gear has been ruined in a lot of different ways. For instance, burned up, $12,000. Blown, $3,000. Lost, $680. Crunched,
Watch it.
$80,650.
Hey, Bob.
Yeah.
Come on, let's go to chow.
Gone,
Look what you did.
$8,000.
PC board, come on.
Carelessness costs the Navy millions of dollars each year, almost all of it preventable. Here are some actual examples of how improper packaging caused additional damage to items being returned for repair. Note in this instance that no effort was made to protect the delicate equipment jammed in this plain cardboard carton. A single shipment such as this could add many thousands of dollars to repair costs. This shipment was made on a specially built wooden pallet to accommodate the range of items included. Note that fragile avionics gear was packed underneath heavy landing gear struts and other aircraft structural members. The avionics equipment, predictably, suffered substantial additional damage during the 1,500-mile transit to the repair site. When a fragile, easily damaged assembly is BCM'd, it should always be packaged for shipment in the external reusable container in which it came. This container, designed specifically for this gyro, will minimize shipping damage. Because of their extreme sensitivity to shock damage, gyros should never be shipped without adequate protection. If the proper reusable shipping container is not available, gyros must be prepared for shipment in accordance with current publications for packaging repairable assemblies. This publication is available through the supply office. Many items, such as PC boards and modules, are not issued in specifically designed containers. For these items, several sizes of standard reusable containers are provided for shipment back for repair. Some fragile items are not issued in a reusable container and will not fit properly in the standard size containers. When these items are BCM'd, again, check the latest publication on packaging of repairable assemblies. A lot of bother? Sure. But if your TV set needs repair, would you take it to a repair shop like this? Or would you take the time to handle it properly? So, it's vital to take the extra time and effort to make sure that repairable assemblies are never shipped without adequate packaging. If the supply of proper packing material is exhausted, adequate substitutes may be obtained from other sources aboard ship. Search until you find an adequate substitute. A possible source is any place incoming material is unpacked. The repairable assembly should be surrounded with the packing material for maximum protection. Items should normally be packed separately. However, if more than one item must be packed in the same box, care should be taken to ensure that there is no direct contact between the various items. The end result will be a package that can withstand normal shipping shocks. Remember, non-RFI assemblies must always be handled in the same careful manner as RFI items. Today, the Navy has a more difficult and demanding role in our country's defense than ever before. All sectors of our economy are competing for a diminishing supply of natural resources. Millions of dollars. Months of lead time. Precious lives can be saved by simple adherence to handling, packing, and shipping procedures. Save external reusable containers issued with original equipment. Store them where they can be recovered when needed for shipping BCM items back for repair, even if it means extra effort to locate a space to stow them. Never deliberately discard a reusable container. For supply stowage, use the stowage containers that are available for gyros and other delicate items. These simple procedures will not only save millions of dollars, they will also save you countless hours of redoing paperwork and replacing parts that would have been RFI with proper handling. And most important of all, these techniques could very well save a plane from crashing, a pilot from losing his life.